Reinforcement learning became very popular all of a sudden in October 2015 when it made the headlines. The game of Go is a game that is very complicated. It's way more complicated than chess. And creating an AI system that could beat a grandmaster in Go was something that hadn't been done before that date. When Google DeepMind, a London-based artificial intelligence company, created a reinforcement learning model based on deep neural networks that managed to beat one of the best grandmasters in Go in the world. Since then, reinforcement learning has become more popular, and its applications are being examined not only in Go, but in other similar contexts, including video games or even real-world simulations. Many researchers believe that reinforcement learning could be one of the keys that will let us create algorithms and robots that start to look more human and more intelligent. Semi-supervised learning is another area of machine learning that's not so popular, but it can be very powerful if it's used in the right way. So there are some domains where we have a large number of unlabeled data. Let's take computer vision, for example. We might have 10,000 labeled images where a human labeled an image as the image containing, let's say, a person or an animal. And maybe the same dataset will have 90,000 unlabeled images. Hiring a human to do the same work again, that is, to label its example manually, can be very time-consuming and can also be very expensive. Well, semi-supervised learning concerns techniques that try to use some of the unlabeled data by using information from the labeled instances. So, to give you an example, in this case, we could build an algorithm based on the 10,000 examples, and then label some of the unlabeled examples for which we have a high confidence in our classification. So maybe for 5,000 of the 90,000 examples, we have a high confidence score as to whether this includes a person or an animal. Then we include this into our original dataset and we iterate this process. So if you are in a domain such as maybe natural language processing or computer vision, where it's easy to find lots of unlabeled examples, but labeling them can be costly, then semi-supervised learning can be a very powerful technique to use. And finally, we have active learning. So active learning is a subfield of machine learning, which once again, it's not very popular, but it can be very powerful if used in the right way. So active learning is based on the idea that not all examples are created equal. Let's take a look at the example at the bottom. On the left-hand side, we have a graph where we have green squares and red triangles. And we want to find a way to separate the two. So we want to draw a decision boundary between the two. And there are many ways to draw a decision boundary. One such way, we can see it in the middle. However, when we notice the middle picture, we see that the examples that are on the far left or the far right, they don't look very informative. So the examples which are the far left, they don't really tell us much that we couldn't learn from the examples that are closer towards the middle. When we'll take a look at the image on the right-hand side, then we can see that these examples seem to be very important in determining where the boundary lies. It seems that these examples were shifted a bit to the left or to the right, the decision boundary would be much more different. So, in this case, these examples are much more informative than the ones that are on the far left or the far right. So what active learning is effectively trying to do is to actively query for the labels of examples which it considers to be the most informative. So in this case, a good active learning algorithm would not just go through all of the examples and use all of these in learning about the boundary, it could single-handedly pick out the examples which it considers most useful, the ones which are close or seem to be close to the decision boundary, and then query about the truth of those labels and use only those for learning. So what we call here an oracle is basically someone or something that has the answers. So the active learning algorithm might actually query a human, or it might just get the answers from a database. So active learning can be a very powerful thing to use in some situations where you don't have a large number of examples, or you need input from a human, or you want to speed up learning. Again, it's not very common to see applications of active learning, but some of them can be pretty impressive, since you can have some algorithms that can learn very fast by getting feedback from a human over only a few iterations. So this was Stelios from the Tesseract Academy. Thank you for sitting through this video in which we covered the different types of machine learning. I hope this video helped you understand a bit about the different kinds of machine learning and where each type can be used. Machine learning is one of the most powerful technologies that have showed up in the last 20 to 30 years. It's on a rise, and with no doubt, we're going to see more and more applications of it coming out. So if you want to learn more about the subject, then stay tuned in the channel of the Tesseract Academy, and I hope to see you once again in some other of our videos. So this was Stelios from the Tesseract Academy. Thank you very much, and see you soon.